This is a project overview of my Open Z v30 chassis and body. This time is the F40 body over the new chassis. So the body have been DLP printed. I guess it wasn't clear on when I post the pictures on the group, because of a few people seems to be confused if the body was also 3D printed. So yes, this body is 3D printed. Is printed with resin using my Mono X 3D printer. I'm going to leave a few pictures of the process in this video. So, well, the body has all details that I could get on it. It even has clear headlights. This one, they don't look as good looking as I would like. I will try to make them again. I'm just starting to use this clear resin, so I'm not sure about settings and post-processing, but for a model it looks quite good. Okay, the side view mirrors are FDM printed on TPU, so they are flexible, so they don't break with crashes. And also added this front bumper for, well, to avoid these little scratches when I'm driving. But, well, I guess it's it's inevitable. But, well, this is a model. As you can see the printing lines, but the painting hide them very well. It had some really nice details, like the F40 embossed logo here. The air intakes has everything. Okay, has even the little bolts of that holds the rear wing. They are there. The fuel cap, everything. It might need a little bit of panel line paint to make them show, but I like it this way. So let's overview the chassis. The chassis is 89 millimeters wheelbase. Everything is 3D printed, except of course the rear axle, the motors, the electronics, the servo, and the screws, and about 8 bearings. Also, I'm going to test if I can 3D print bearings. I mean, not actually bearings, but just, solid parts that have the right dimension. I think it's going to work too. It won't last as long as a real bearing, but it should work. So this chassis represents about 2 years of work of testing. I have made a lot of chassis version. This is the most mature one. It has everything I wanted to be in an Open Z chassis. The first thing that it has front suspension. Right now it's really short. That's just because I wanted to be like a real racing car, so it's quite short. But it can be adjusted here. You see? There's a gap there. If you screw in that screw more, the gap is going to be bigger. So this will raise this traveling distance. So that's adjustable. This screw here can be placed with the head on top, so you can adjust the front without taking the chassis apart. But right now this body is really low right there, so the head will not fit with this body, but it's possible to do. It uses SG90 servo, is here, 10A ASC. Right now I have a 300 milliamps battery, 2S, but it could use even a 500 one, and I think even bigger. You can place a battery up to here. You can place it either this way or this way. They both work. I also leave a little hole. Oh, this one doesn't have it. And this one, this is the lastest version. It has a little hole here in case you want to screw in a clip or something to hold everything down. Just I didn't include it because I'm not using it, but it's possible to have it. For receiver, in this one I'm using the FSBX6 Fly Sky. It has gyro integrated. It works really good, and it's quite short, so you can fit it behind the servo. In this one I'm using a standard generic 3-channel receiver, so it doesn't fit behind the servo, so it fits this way, like this. You can see this better on the instructions, but what I want you to see is that there's plenty of space here to fit almost any electronics. And this is using the F40 body. If you use a taller body, it's going to fit even better. So since it is 89 millimeters wheelbase, it can be easily be adjusted by printing this part, a longer part, a longer suspension, rear suspension plate, and a longer rear suspension arm. So it can be adjusted to 90, 92, whatever you need. In the back, the rear, we have differential. That's, to be honest, that's what I'm most proud of. This took a lot of design to make this work without having to need any threads or any special part. Everything is 3D printed except for the axle and the bearings. And like I said, I think it might work with 3D printed bearings. So you need to have little clearance here between the parts so they all work nicely. It's super smooth, like you can see, and they together. This one is super smooth, especially because I have used it for a while, maybe 4 or 5 batteries, so about 8 hours or more. So it runs super smooth now. This one I just printed yesterday. It's not as smooth. I still have to keep adjusting it to get it to working nicely, but I'm sure that with more use it's going to be even more smooth, so it's no problem. Even like this, it works quite well, so it's really no problem. And the motor is a Earth 130 motor, just the most generic one that you can get. The only thing that you should always be aware is this motor needs to withstand at least 6 volts for the 7.4 of the battery. Ideally it should be 9 volts. I have tested several motors, some of them work, some of them don't work. Sometimes the data sheets on the product description is not correct, so it's, to be honest, has been quite difficult to find the right motors. So good luck with that. I really don't know what else to say. I mean, I have ordered them from Banggood, from Amazon, from AliExpress, and it is always the same. It's just it's pretty much luck. Sometimes they work, sometimes they don't work. I even ordered from Adafruit. I still have to test them. I hope they work just like the datasheet says, but to be honest, I'm not sure now. Of course, the optimum option would be to have a mini C motor here, but well, my goal was to make it as cheaper as possible, so that was not an option. Okay, so well, this is it. It used M2 screws all over the chassis, except for this one that is M2.5, just to give a little bit better grip in here. I guess you could use a smaller one and print this part with a smaller hole, but well, I still have to test that. So for now, this is the one that I'm using. What else? This part I printed on TPU to keep this flexible, but I'm sure you can print it on PLA. Just make sure it's not as thick as this one. This one is 1.5 millimeters thick. If you print it like, for example, 0.5 millimeters, you will still get this movement, so it should work quite nicely. For the tires, I'm using TPU. It works better than PLA, but it's nowhere near the real rubber, you know. With the use, they tend to get they start to get more grip, but like I say, it's nowhere near real rubber. I might try to make silicone tires, something like that, but like this, it works quite nicely. So this is it.